Find the real value of m and n in the exponential equation 2 raised to power m equal to 2 raised to power n equal to 2016. Hello everyone, welcome to our maths class. In our class today, we are going to find the real value of m and n in this Maths Olympiad simplified exponential equation. But before we solve, like, comment, subscribe to this channel in order to get a regular update of our Maths Olympiad solution videos once they are uploaded. Remember, subscription to this channel is absolutely free. Thank you. Now let's solve this question. To solve this question, we are going to apply some simplified logic and skills in mathematics. Now come to see this, that 2016 is greater than 0, right? Good, that is taken. And for 2 raised to power m to subtract 2 raised to power n, that simply tells us that 2 raised to power m is greater than what? 2 raised to power n. So that tells us that m is greater than what? 0 than n. So if n is greater than m is greater than n, that simply tells us that we can simply let our m to be equal to n plus a value x, because m is greater than what? Than n. Now, that simply tells us that wherever we see m, we can simply replace it with what? N plus what? X. Now, let's go back to the main equation. We are going to simplify that into this main equation. So this will give us 2 raised to power n plus x minus 2 raised to power n, and this will be equal to 2016. Having gotten this, remember this indices expression. When we have a raised to power x plus y, this can be equal to a raised to power x multiplied by a raised to power y. Fine. Good. If we apply them here, we are going to have a raised to power n multiplied by 2 raised to power n multiplied by 2 raised to power x minus 2 raised to power n equal to 2016. Guess you're following. Good. So let's take this further. If we take this further, we are going to find a common term in the left hand side, which is 2 raised to power n. Let's bring it out. Once you bring that common term out, we'll be left with what? With 2 raised to power x over here minus, and this part will be left with 1. So this will be equal to 2016. Fine. Having gotten to that part, we want to now break 2016 into a smaller term. Remember, 2016 can give us a value. 32 times the factors of 2016, 32 times 63 will give us 2016. Now, 32 can give us 2 raised to power 5. So 2 raised to power 5 multiplied by 63 will give us the value 20 what? 2016. So let's impute this simplified factor into that expression. We'll have 2 raised to power n raised to power, all in bracket, 2 raised to power x minus 1, and that will be equal to 2 raised to power 5 multiplied by what? 63. Now, where do we go from here? We are going to do some comparison in mathematics that is acceptable. Now, if you come to see this, you come to see that this is an even term. While this is an odd term, this remains an even term. Of course, you know what even and odd means in mathematics. Why this is an even and odd what? An odd number. So what we are simply going to do is we are going to equate the even numbers to the odd number, and then equate the even number to the even number, and then the odd number to the odd number. So even number will have 2 raised to power n is going to be equal to 2 raised to power 5, right? And then on the other hand, we have 2 raised to power x minus 1 equal to what? 63. That's equating similar terms. Now, when we come to this side, you come to see that 2 raised to power n and 2 raised to power 5 have common base. So that common base will clear each common base, and then we left with the powers or the index, which is equal to what? 5. So our n in this expression is equal to what? 5. Now let's come to the odd values. If we take -1 to this other side, we'll have 2 raised to the power x equal to 63 plus what? 1. So this will give us 2 raised to the power x equal to what? 64. Now come to think about this. We have 64. 64 can be equal to 2 raised to the power what? 6, because 2 times 2 times 2 times 2 times 2 times 2 will be equal to 64. Now if we apply that into that expression, we are going to have our 2 raised to the power x equal to 2 raised to the power 6. We have a common base. The common base will clear the common base, and then we'll have our x to be equal to 6. Voila! We now have the solution for x and n. So our n is equal to 5, and then our x is equal to 6. So what do we do with this expression? We are going to put them into that value we assumed. And what is that value? M is equal to n plus x. Now come to think about this. Once we've gotten our n, we've gotten our m, that simply tells us that we can simply find our m, since m is equal to n plus x. So our m will be equal to what? 5 plus 6. And then our m will be equal to what? 11. So we've gotten two expressions. The two expressions we've gotten an expression for n, which is equal to, we've gotten our value for n, which is equal to 5, and then we've gotten our m to be equal to 11. These are the two solutions that satisfy the equation. Now let's come to check if our solutions are correct. In the checking section, we are given 2 raised to the power m minus 2 raised to the power n. And whatever this gives us, it must give us 20 what? 2016. So we have our 2 raised to the power m is 16, 11 minus 2 raised to the power n is what? 5. So what would this expression give us? 2 raised to the power 11. Let's look for a calculator and point our calculator. 2 raised to the power 11 will give us 2 raised to the power 11 will give us 2048, right? The next thing we want to do is to find 2 raised to the power 5. 2 raised to the power 5 will give us 32. So 2048 minus 32 will give us 20 what? 16. Voila! That tells us that this solution is absolutely correct. I know you did enjoy this solution. For more simplified Maths Olympiad solution, don't forget to like this video and subscribe to this channel in order to get more updated solutions. Thanks so much for watching, and don't forget to share these videos with your friends.